Hello, we are Memphis Community University, and today we are doing another calculus done wrong lesson where we wrong calculus before calculus can wrong us. And today we are going to be finishing our integration topics playlist, which introduced a lot of key concepts like Riemann sums, integrals, the fundamental theorem of calculus itself over 3 videos. Definitely the most important part of my life. I don't know about you guys. But today we're going to do a slightly less important topic, which is going to be average value. But average can be quite tricky. Some of my students get confused about it. Maybe it's because I'm not explaining it well. That's probably the reason. But the problem with average is that students confuse it with a similarly named thing, which is average rate. So in this video, what we're going to do is we're going to introduce formulas for both average value and average rate. And hopefully, when you recognize when to do which formula, each formula itself is not very hard to execute. So the hard part will be choosing which formula to do, setting up the correct formula, and then once you have the formula, you'll be good to go. But let's get started. Hard to talk about this without the formulas themselves. So for the first half of this video, I'm only going to do average value, or not the first half, maybe the first third. We're going to do one average value question, and then what we're going to do is we're going to do some average rate questions. I know you're excited, but we're going to be able to survive this. Well, let's just get started. Don't know what I'm saying anymore. So let's do average value. So what's the definition of average value? Well, average value of f over an interval. So we're always going to do the average value of f on an interval, like 2 to 7, for example. So we're going to write on A to B. So the average value of f graphically is, if you have a function like this, whatever, the average value is the height, the middlest, if that's a word, the most middlest value, the most middlest height of that function over the interval 2 to 7. So if it's going like this big from around here to here, well, the average height is probably around here. Not the best graphical interpretation, but the graphical interpretation actually doesn't matter that much. Again, it's the formula that matters. And what the formula will be is 1 over b minus a. So that's the interval. So it's the right endpoint minus the left endpoint in a fraction times the integral. So just a few things to keep in mind here. What you are integrating is very important, what to put in the integral. So what I tell my students is, if you're finding the average value of f, you put that in the integral. So average value of f, you put f in the integral. If we were finding the average of velocity, we would do 1 over b minus a, the integral of velocity. If we were finding average temperature, 1 over b minus a, the integral of temperature. If we were doing the average of espeon here, it'd be 1 over b minus a, the integral of espeon. So that's all good to go. Just keep in mind that there's going to be various ways, of course, to find the integral. In this video, what we're going to be mainly doing is taking antiderivatives, because we just learned that skill. We might as well use it as much as possible to show the world what we got. But sometimes you're going to be approximating it with a Riemann sum. Sometimes if you're lucky, you might be evaluating it with a calculator, area under the curve maybe. But in this case, what we're going to be doing is mainly antiderivatives. But no matter what method you do in order to evaluate the integral, you do need to multiply by this number in the front. Just keep in mind that that's basically the only thing to do. So that's why this formula is not too crazy. Average value of f, do the integral of f as we've been doing in the previous few videos. Just multiply this one number at the end. And by multiply, I'm really dividing because you're dividing, multiplying by a fraction. So let's see this in action. So this is our example. So let's say we have this function. Let's do 9x squared. Let's do minus 4x plus 2. And we're going to be on the interval. Let's do -1 to 2. So hopefully we didn't choose too big of numbers. But this is again f of x. This function, we're going to try to find the average of this function on this interval. So we have this formula right here. Let's just set it up in the context of this question. So in this case, a is -1 because that's the left endpoint. So that will go in the lower limit. B is 2, so that's going to go in on these 2 spots. And then finally, we're going to be integrating this function, this lovely little guy right here. So let's first set it up, and then once we set it up, we will do the integral. So it's going to be 1 over 2 minus -1 As usual, negatives can be kind of confusing, so keep in mind that there's two negatives in this case, negative from the formula and then negative from the left endpoint. Then we're going to write our integral. Before we write the integrand, or what goes inside the integral, that's actually going to be the hardest choice because sometimes it's not the given. But in this case, we're going to put this one, but the numbers are pretty easy. It's going to go -1 to 2, bigger number on top, and then we're going to write this integral out. 9x squared minus 4x plus 2. We're going to write times dx. So what we're going to do is we're going to evaluate this integral again and then multiply by this number. So what is this? This is not too bad. This is 1/3. We'll write it right here. Hopefully you can see this. And then we're going to have to do this integral with ways we learned previously. So what we're going to do is we're going to do the power rule, of course. So what happens is you add 1 to your new exponent, and you add 1 to form your new exponent. So it's going to be x cubed. 2 plus 1 is 3. So 3. So just keep in mind that this 1/3 again, which over here, so in this bracket is where I'm going to write my antiderivative. So you add 1, so it's x cubed. Then you divide by your new exponent or flip your new exponent. So there's going to be times 1/3, but 9 divided by 3, or times 1/3 is just 3. So that's why we're going to have 3 here. Let's practice again. So when we have minus 4x, that's technically 4x to the 1. So when you add 1, it'll be x squared. So it'll be x squared. Divide by our new little exponent. So that's going to be 4 divided by 2, which is 2. Keep in mind that there is this negative, so it's going to be -2. Plus 2. What's the antiderivative of that? That's just going to be plus 2x. So this is the antiderivative. Don't feel bad if you're not the greatest at antiderivatives yet. You will eventually get there once you do a lot of practice, just like with every single math concept usually. Just keep in mind that if you are uncomfortable a little bit, if you want to check yourself, that's always an option. So you just take the derivative of the thing you just found, and hopefully you'll get back the same thing. So if you do the power rule, drop this exponent like it's hot to the front, it would be 9, and you subtract 1, so you would get 9x squared. Same thing here, you can check that you would get minus 4x plus 2. So now what we're going to do is we're going to evaluate the antiderivative because it's a definite integral, and we're going to plug in 2 into the antiderivative, and then we're going to subtract, plug in -1. But remember, this guy, we have a watchful eye on this guy. We know that it's still here. He is not going to sort of escape our vision, I guess. I don't even know what I'm saying anymore. But just keep in mind that this 1/3 is still very much here. We will deal with him at the very end. Save the best for last. So again, what we're going to do is we're going to plug in 2, and then we're going to subtract, plug in -1, and then just do math. Multiply by 1/3 at the end. So let's see this. When we plug in 2, we'll write the 1/3 just to not forget him. When we plug in 2, it's going to be 2 cubed. Can I do this math? Maybe. 2 cubed is 8. 8 times 3 is 24. Well, let's just write 24. I don't want to do that much more math. Not a calculator. 2 squared is 4. 4 times 2 is 8. Put 2 at the very end, I think we're going to get plus 4. And then we have -1. So when you plug in -1, you're going to get -1 cubed. That's -1. So that's going to be -3. When you plug in -1 here, it will be -1 squared, 1. You can do all this math, I'm assuming. 1 times -2 is -2. You're probably better than me at this. 2 times -1 is -2 as well. We are doing the fundamental theorem of calculus, so note, remember that it's the upper limit into the antiderivative, subtract, you know? Subtract, plug in the lower limit. So in this case, it's going to be a minus here, as not in most cases, every case, when you're doing the fundamental theorem of calculus. So then finally, we just need to find this guy. Again, this is just math. 24 minus plus 4 is 8, 28 minus 8 is 20, so it looks like we have 20 over here. Then there's going to be some negatives that we have to deal with, but it's going to be minus 5 minus 7, so it's going to be minus 7, there's going to be 27, because it's 20 plus 7. 27 divided by 3 is 9, I believe. There's like a 70% chance that I just missed that, but the actual evaluation of the integral is not the most important thing. So again, notice that we haven't really done anything new. We did this integral just like we've done previous integrals in the previous videos. All we did is we just have this guy in the front when we were doing average. which is multiplying by the reciprocal of the length of the interval. Average value is not very hard to set up. Set it up, multiply by the number after you take the antiderivative, if you are taking antiderivatives. So this is not where it's difficult. If there were only average value questions on the AP exam or on college exams, then people wouldn't miss this. They would just always set up this formula. It's when you add it's when you introduce the concept of average rate that it gets harder. Now is the time, friends. Now is the time. So I'm going to first talk about average rate a little bit. This is the average value of f. Now we're going to be talking about average rate of f, which is slightly different. The wording is a little bit confusing. Unfortunately, you have the word average in both of these things, but as we'll see, there's a huge difference between average and average rate. So you're always thinking about average rate as a phrase. Average rate, average. Average rate, average. They're two separate things. So let's talk about average rate now. So average rate of f, it's still going to be over an interval, and there's going to be two formulas. And that's why it's a little bit tricky. So the first formula comes from the previous formula. So it's going to look pretty similar. It's going to be 1 over b minus a to b, dx here. If we put f of x, that again was average value of f, but average rate is the same thing as the average of f prime because rate is the derivative of f. It's f prime, so it's average of f prime. So if you want to find the average of anything, you put that thing in the integral, so we're going to write f prime of x here. So this is this formula. And then there's a second formula, and what the second formula comes from this formula right here. And what happens is you just do fundamental theorem of calculus, the greatest thing in the world, of course. So when you take the integral of f prime, the antiderivative of f prime, that's just f. You're going to evaluate the upper limit and the lower limit. So that's why you just get f of b minus f of a. Let's divide these two formulas. And then when we multiply by b over minus a, that's again it's the same thing as dividing by b minus a. And we're going to write it like that because it's pretty easy to recognize. So again, this comes from fundamental theorem of calculus by evaluating the upper limit and the lower limit at the antiderivative. But notice, what is this? This is algebra slope. This is an old friend of ours that hasn't appeared in a while. So this is where it gets tricky for my students, so I'm going to try to emphasize this as much as possible. So you have average rate of f. Unfortunately, we have free will, and free will is bad. We don't want to make choices. We want to just be told to do something and do it. But in this case, what we're going to have to do is for every single average rate question and perhaps some average questions, what we have to do is we have to determine which one do we want to do. Do we want to do this little guy right here, or do we want to do this guy? We want to do this guy or this guy. And of course, they're both valid because this one comes from this one, and this one comes from the average formula. So the question is which one to do. Well, it's going to be based off the givens and not what the question is. So if you're finding the average rate of f, if you're given f prime, as you might expect, you're going to do this formula because notice this formula has f prime. If you're given f, so it says here, find the average rate of f, here is f, then you're going to be doing this formula because this is the formula that has f. So again, f prime, f, f prime, f, f prime, f. So let's see this in action. So let's say we're trying to find the average rate of f, and then we're going to do the average rate of g to switch it up. And let's say we are given the fact that f prime of x, we'll keep it kind of simple here because I don't have a lot of space. Let's just write it as 2x minus 1. We're going to find the average rate of f over the interval. Let's do, hopefully you can see this. I don't even know if I'm blocking this, but it's 1 to 3. We'll do over g as well. But in this case, we're going to have g given and not g prime, and we're going to have the same given. Let's just have to call it the same function to be as confusing as possible, because my philosophy when I'm teaching math is try to confuse students every once in a while just to keep them on their toes. So we're going to do this question and this question. Again, let's really focus on the setup of the formulas, because once you have the setup of the formulas, each of the formulas aren't too bad to actually evaluate by themselves. So set it up, take a little bit of time, you know? Sometimes you got to take a little bit of time at the very beginning of the question. Don't want to rush through it. Just take your time and everything will be good. So before we go through this question, we're going to have to ask ourselves, which one do we want to do? So without looking at any of this, we're finding average rate of f and we're given f prime. We think about, oh, average rate. This is the annoying question. That's two choices in terms of which formulas am I going to do. I'm going to look at my given. My given is f prime, so that means that I'm going to do the formula that has f prime. So I'm going to set up this formula right here. So in the context of this question, it's going to be 1 over 3 minus 1. That's the length of the interval. Then it's going to be integral from 1 to 3. So it's the integral of 1 to 3. And then we're going to put f prime inside the integral as so. And just like the previous one, we're going to evaluate this integral, plug in the top number, plug in the bottom number, and we should be good to go if we multiply by 1/2 at the end. So this is going to be 1/2. This integral isn't too bad. It's just x squared minus x. Be sure to check me on that. And then we're going to plug in 1 and 3. Hopefully you can tell this is so small. My shadow is blocking it, but this is x equals 1, x equals 3, because those are the interval. We're going to plug in 3. It's going to be 9 minus 3, which is 6. If you can't see this, just listen to my voice. If you plug in 1 here, that's nice because we get 0. 1 minus 1 is 0. Still going to write that 0, and then remember to divide by 2 or multiply by 1/2. That's the same thing. Looks like we're going to get 3 here. So hopefully you can tell that. Again, sorry that this is so small, but I wanted to have both questions in the same shot. So that's this question. It was very similar to our first practice question because we were given the same thing we're taking the average of. Average rate, f prime. So now what we're going to do is we're going to do this second average rate question. And you'll see that even if we're doing the same question, because the givens are different, our entire work will be different because we'll be doing the different formula, the second formula. So I read this question, average rate, and I'm like, oh my gosh, it's average rate. So I have to think, which one do I want to do? Do I want to do the integral formula or do I want to do the slope formula? Well, because we're given g, because we are given the antiderivative of the thing we're taking the average of, the derivative of g, what we want to be doing is we want to be setting up the algebra slope formula. One of the only formulas in calculus where you don't take a derivative or an integral because that's already done behind the scenes to arrive at this formula. So in this case, it's just going to be g of 3 minus g of 1 over 3 minus 1. I don't know about you, but sometimes it's nice to talk to old friends like algebra slope. Like we have our new friends, Riemann sums and fundamental theorem of calculus, but sometimes it's nice to go to our old pals and sort of gossip about our new friends behind their backs. So let's do this real quick. Let's do g of 3 minus g of 1. Again, no derivatives, no integrals. Like, look how nice this is. If you can recognize that it's algebra slope, it's the easiest formula to use, actually, because you've been using algebra slope for a while. So it's going to be divided by 2, because 3 minus 1 is 2. And then all we're going to do is we're going to plug in 3, and then we're going to plug in 1. When we plug in 3, looks like we're going to get 6 minus 1. That's going to be 5. And then finally, when we plug in 1, it's going to be 2 minus 1, which is 2 minus 1. Hopefully you can tell what I'm doing here, plugging in 1 here. And when you do that, you'll just get 1. So it's going to be 5 minus 1, which is 4. 4 divided by 2 is 2. So again, notice that no matter which one you're doing, the actual work isn't too crazy. It's just choosing which one to do. And again, there's two formulas based off the givens. If you're doing average rate, if you're given f prime, you want to be doing this. If you're given the derivative, you're going to be doing this. If you're given the antiderivative, you're going to be doing this. So that's general rule of thumb. What sometimes I like to say is if the function matches the thing you want to find the average of, the given, that's when you're going to be doing the integral, as we'll see in the context of particle motion. If you're given the antiderivative of the thing you want to find the average of, that was an example right here. We were given g, we were finding the average of rate of g, which is the average of the g prime. So we were given the antiderivative of g prime. I know this is super confusing. We were doing algebra slope. So let's see this in the context of particle motion, and we should be good to go. So I'm going to erase this guy right here. let's do this. Let's erase this, and let's talk about averages and average rates, sort of in the context of other things. So again, it's kind of hard. Do I do the integral formula or do I do the derivative algebra slope formula? So let's talk about it in a very generic sense in terms of temperature. So if we have temperature, let's say we're given temperature and we wanted to find average temperature. Well, which formula will we do? Well, that's the same thing as our espion example from before. If you're given the thing you're taking the average of, you're going to be doing integrals. So let's call this T of T or something. So this formula would be 1 over B minus A, the integral of temperature. These are the same formulas as with our just generic functions. Let's say we're trying to find the average rate of temperature. Well, there'd be two possibilities, just like every single time. The first possibility is it's just going to be 1 over B minus A, the integral of A to B of T prime instead. And then the other formula that it could possibly be is T of B minus T of A over B minus A. So let's just talk about this real quick. Let's say you're given this temperature function. If you're finding average temperature, you're going to set up this formula right here. If you're finding average rate of temperature, if you're given the rate of change, if you were given T prime, for example, but be careful, sometimes they don't call the rates actually derivatives because they're trying to trick you because they're really mean. But if you're given the rate of change of temperature and you want to find the average rate of temperature, that thing matches. So that's why you're doing the integral. But if you're given temperature and you want to find the average rate of temperature, temperature is not the rate of temperature. Temperature is the antiderivative of the rate of temperature. So that's when you set up algebra slope. So again, sometimes my students memorize is that if it matches, you're setting up an integral. If it's the antiderivative, the given is the antiderivative of the thing you want to find the average of. I just said the word derivative really fast. That's when you're doing algebra slope. So let's see how it's the most confusing, which is in particle motion. So let's say we have velocity. So always there's two formulas for average velocity, average acceleration, things like that. So let's talk about average velocity in this case. So average velocity. So there's two formulas for average velocity. Well, remember that the average of anything is 1 over B minus A, the integral of that thing. So for a given velocity, we're going to be setting up this formula right here. 1 over B minus A, the integral of velocity. That's in little b if you didn't know. Let me try to mark it out. Let me try better. That's not the greatest, but whatever. So again, if you're given velocity, you're matching the thing you're trying to find the average of. If you're given espion, you're doing 1 over B minus A, the integral of espion. If you're given velocity, you're doing 1 over B minus A, the integral of velocity to find average velocity. But there is an equivalent algebra slope formula, and that's when you're given position. Because we can reword average velocity as the average rate of change of position, because it's the average of the derivative of position. So in this case, we would be given the antiderivative of the thing we want to find the average of, even if we're still trying to find average velocity. And so those don't match, which means it's actually the easier formula. It's actually just algebra slope. So this would be S of B minus S of A over B minus A. So again, notice we're finding average velocity in both of these questions, but there's two formulas to choose from. They're both valid. If you're given velocity, that's the same thing as you're taking the average of. You set up the integral formula. For this one, if you're given position instead, that's the antiderivative of the thing you're taking the average of. So you set up algebra slope. So hopefully this makes sense in terms of how to choose which function to do. It's all based on those original functions and sort of the definition of what rate is. Average rate can be possibly two things. It can be an integral or it can be an algebra slope. So let's practice one last time and then we will be good to go. Sorry this has been so long, but I'm trying to really stress the difference between choosing which one, because once you choose which one, the question isn't too crazy. If you want a rule of thumb or sort of a general chance or in terms of how they like to ask it on the AP exam, if that makes sense, it's usually the algebra slope formula when you're doing average rate of change. I'm going to make up a number, but it's like 78% of the time or so. But you want to know how to do each one because we want to answer 100% of the questions because we're that good. So let's do this last thing. Let's talk about average acceleration. And we're going to do it over the first 3 seconds. And we're going to have 2 particles. So particle A, we're going to have its velocity be given. So we're going to call it v of a t. And we're going to keep the velocities again pretty simple. Let's just call it, let's see, let's do 4t plus 1. Shouldn't be too crazy. For particle B, why have only 1 particle when you can have 2 particles? So particle B, we're going to switch up the givens, of course, because again, the givens determine which function you do. If it matches, you do the integral. If it's the antiderivative of the thing you want to find, then you're going to be doing algebra slope. So particle B, that's going to have acceleration given instead. So we'll call it a of b of t, and we'll just do the same function to make things confusing, of course. So why don't you pause the video just for 3 seconds, or I'm going to pause for 3 seconds. You pause the video. You try to at least set up these guys and just try to determine which formula you're doing. If you're bold and brave, you might want to try to do them on your own. And after 3 seconds, I'm going to reveal the answers sort of to the world. So 1, 2, 3, let's get going. So I'm going to take them separately because they're 2 separate questions. And then again, I'm really focusing on the givens. So in this case, notice that we're given velocity and we want to find average acceleration. No match. So that means that because we're given the antiderivative of the thing we're taking the average of, this is the nice formula actually. This is going to be algebra slope. So let's get going. So this is going to be algebra slope of this function right here, velocity. Oh, keep in mind that we've talked about this in particle motion before. You do need to write this as an interval. We've done this with absolute max or min velocity. We've done this with things like speeding up, slowing down. First 3 seconds, just keep in mind that means from 0 to 3. The first 3 seconds. So in this case, we're doing algebra slope where these are 2 points. So how do we set this up? Well, it's going to be v of a of 3 minus v of a of 0 over 3 minus 0. So when we plug in 3, that's going to be 12. Plus 1, that's going to be 13. When we plug in 0, 4 times 0, I believe, is 0. Add 1, you're just going to get 1. So it's going to be 13 minus 1. Look how nice this is. Like, it's so nice when you're like, oh, it's algebra slope. That's great. No calculus, because calculus, bad. So pretty easy stuff. Just subtracting, dividing. Looks like it's going to be 12 divided by 3. That's 4. And again, we had this luxury of doing this easier formula because the givens didn't match. We were given the antiderivative of the thing we're taking the average of. So you can imagine that this last question, we're going to end on a bang, a little bit harder of a difficulty question. This is probably going to be the integral formula. And why is that the case? Well, looks like we're given acceleration here. For particle B, we want to find average acceleration. We're matched the thing we want to find the average of. Here's F, find average of F. Here's Espion, find the average of Espion. I like my guy Espion. Here's acceleration, find the average of acceleration. So in this case, what we're going to do is set up the integral. And I mentioned set up the integral, set up the algebra slope. And just remember every single time, when we set up that integral, when we're doing average, we are going to remember the 1 over b minus a, because that's the point of the formula. So in this case, it's going to be 1 over 3 minus 0. Integral from 0 to 3. 4t plus 1 dt. Potential ways to do integrals: Riemann sums, antiderivatives, calculator in the area maybe. But in this case, we're going to be doing antiderivatives because we just learned that skill. But it's not going to be too bad because it's not the hardest antiderivative, of course. So we have 4t here. the original exponent is 1, so we add 1 to that old exponent to form a new exponent. That's going to be 2. We're going to divide by this new exponent of this constant. 4 divided by 2 is going to be 2. Then we're going to take the antiderivative of plus 1. That's going to be plus t. We're going to plug in 3 and 0 slowly. So it's going to be t. Sorry, I'm getting messy. At the very end, I could have been a little bit neater, but sometimes you sort of lose gas. When you plug in 3, it's still a fundamental theorem of calculus, so we're going to plug in the top number, and we're going to subtract, plug in the bottom number, being careful with parentheses. But when you plug in 3, looks like we're going to get 9 times 2, which is 18. 18 plus, wait, let's just write this out. I don't know what I'm doing. So it's going to be 18, hopefully you can tell this, plus 3. Cool. And then when you plug in 0, that's always the greatest, because plugging in 0 in this case gives us 0. It will be 0 plus 0. So we'll write that real quick. It is fundamental theorem of calculus, so I am going to write minus, because I do want to focus that it's always minus, minus, minus when you're doing fundamental theorem of calculus. And then for average, just do not let this guy escape. Right here. Look at this guy. Look at him. Look at him. Right here. Right here. Look at him. Right here. Remember this guy. Don't get so excited to take the antiderivative that you forget about this guy at the very end. That'd just be so sad. Just remember that at the end, we do need to multiply by 1/3. So 1/3 here. And then this is not too bad of calculations. 18 plus 3, 21. 21 divided by 3. Let's just call this a day. This is going to be 7. So again, not too bad. Focus on choosing the right formula based off the givens. Let's just have a little bit of a recap here. So we talked about 3 formulas mainly, but these formulas are intimately related, and that's what makes it difficult, what makes students a little bit confused, because it's hard to choose which formula to do. So let's just recap which one to do, and then we'll be good to go. So we talked about average value. The word value doesn't really add much, but average of f would be the same thing as average value. The most important word is average, the one I abbreviated, so maybe let's not abbreviate it. Let's just write it as average. Let's not be lazy at the very end. So average value of f on a to b, that's going to be 1 over b minus a, the integral of a to b, f of x dx. That's the generic formula, not too bad. No rate in terms of the phrase, so you don't have to choose between which one to do. Then we learn about average rate, which is again the harder one because there's 2 formulas. It's usually algebra slope, but it's not always algebra slope because of depending on givens. So perhaps I'm doing this recap so I can do a little squiggly dot. No, that's the worst one. Let me try again. So there we go. So there's 2 formulas. It's going to be 1 over b minus a, the integral of f prime instead, because we're finding the average rate of f. That's the average of f prime. Or if we're lucky and we're given f and we're finding the average rate of f, we saw that with given velocity, trying to find the average of acceleration. So given the antiderivative of the thing we're taking the average of, that's going to be algebra slope. And that's all she wrote, basically. Just choosing between these 3 functions depending on what are given. So if f prime is given this, f is given this. So hopefully this has been a clear enough explanation on when to choose which formula, how to set up each of the formulas, what to do with those integrals, some sort of tips along the way. Don't forget about this guy, choosing the right formulas, things like that. As usual, we had a Girls Teach Calculus video practicing this concept. One of my former students made a video where she does a lot of average questions. She first finds the average value of various ways to find integrals in the context that we know. Then she does some average height questions, average temperature questions, average rate of temperature, and then those average particle motion questions that people have trouble with choosing the right formula. She probably explains things more patiently than I do, so be on the lookout for that. That's, of course, in the description below. Like and subscribe if you found this video useful. This, again, is the end of our integration topics video. Hopefully, we'll see you in our next playlist when we practice actually taking integrals at a higher level. We'll do some integrals that are split numerators. We might do some absolute value integrals, and then we're going to be doing u-subs, of course. So hopefully I'll see you then. Thanks again for watching, and goodbye.